project. It's based out of Algonquin Park. My field species is the Midland painted turtle. So a common turtle in Ontario, kind of a northern part of its range. Where my field site is located, there's an old railway embankment which was built in the 1800s. The railway has obviously been taken out, and it's left with a sandy embankment through 3 wetlands. So we have Blandings Bog, which is a low density site, Wolf Hall Pond, which is a high density site, and West Rose Lake, which is a medium density site. In the spring, we go out there and we just try to catch all the turtles that we can, take them back to the lab, process them, measure their carapace, weigh them, that sort of thing, give them IDs. Once we've processed them, we will write their number on their back so that we can see them during the nesting season or know that if we've caught them. Once nesting season starts, which is start of June, end of May, we go out there and we're walking this embankment between the 3 ponds. It's about a 2-kilometer stretch. We walk it from about midday until when the turtles finish nesting. Roughly for a painted turtle, they usually finish nesting around dark, so when a turtle is wanting to nest, they kind of look for specific characteristics of the soil. So they look for like an embankment that's on a certain angle, a certain substrate, sand, and sand on an angle is very good for drainability, so the eggs aren't going to get super wet. If it's facing south, then it has sun for most of the day, low vegetation, low canopy cover, so it's not being shaded. The soil is going to be nice and hot. Because the season is so short, there's only about 2 months of really warm temperature in Algonquin. And it takes about that time for gestation of the eggs. So if it's a really cold, wet season, the eggs might not actually have enough time to develop and hatch in the coming fall. So we're walking along the bank and we're looking for turtles. We see them coming up. We start writing notes. Staging is when they're in the water. Landed is they just landed. Searching is they're searching for a spot to look, or to lay their eggs. We then have plowing, which the turtles put their faces into the ground, kind of push up the dirt, and they'll do this until they have a cavity formed. And the females, you can actually tell if a female is coming up, and let's say we think it might have laid. You go over, pick it up. If it pees, then we know it hasn't, because they kind of fill up their bladders with water, and they use this to help build the flask of the cavity. So when they're digging, they'll pee into it and kind of hardens the interior flask shape of the cavity. So they dig for about half an hour. The actual laying of the eggs can be less than 10 minutes. And the nests can be, for painted turtles, they're very good at hiding their nests. So if you saw a turtle nesting and then you're watching it cover and you walk away and you come back and it's gone, it's very hard to actually find where it is. It takes an experienced turtler to kind of see what you're looking for, and they grab pine needles or whatever's around and kind of throw it all over, so like there's not really a pattern, versus a snapping turtle where there's these kind of big mounds where it was, and it's very obvious. So while we're walking along the embankment, we have flags, and when a turtle comes up and it starts digging, we'll write down it's digging, we'll write down the time, we have the temperatures and everything like that. We take soil, water, and air temperatures. So we'll toss like a little flag towards it so we know where it is. Once it actually starts laying and covering, we kind of time it, our walk along the embank, so that we can end it when it's finishing covering or just leaving. And then we can use one of these big stakes, plunk it down half a meter away from it, put its ID on so we know where that nest is. And then later on that day, once all the turtles have finished nesting, we'll come back, dig it up, take all the eggs back to the lab, measure them, weigh them, and then the next day actually bring the eggs back and put them in that nest chamber, so we have data on female clutch size and female egg size and that sort of thing. So for my project specifically, I recreated a grid system that we used to have on the turtle project. So the turtle project's been going for, I believe this will be its 44th year. So it's actually now the longest turtle project in North America. So I recreated this grid system along the embankment, and then once turtles lay, I kind of used the old measurements that the old researchers had used, where I would measure from one stake to the nest and then from the stake on the other side to the nest, so I kind of get like a triangulation of where the nest is. And then with that, I can tell whether they're coming back to the same spot. So for my research, my main question is whether painted turtles have nest fidelity. So fidelity is a tendency for a female turtle to return to the same location or microhabitat each year to nest. So with these grid sections, I'm going to be able to see whether they come back to the same spot or not, or if it's part of the time, that sort of thing. And then the other part of my research is what's driving this. So the two main things that I have is search time and nest predation. So search time is just the amount of time that a female takes to go up, find a nest, dig a nest, then return to the water. And for turtles, going on land is very risky. Nesting is actually probably the riskiest thing a turtle can do in its life. So it's going up on land. Usually they're in the water. Going up on land where there's predators. They do have hard shells, but many predators, foxes, coyotes, a lot of corvids, ravens, and crows know how to flip them over and kill them if they can. And then during the nesting process, with all these hormones and stuff that are going on, they're kind of in a vulnerable state where, let's say for example, a turtle is nesting. Like I wouldn't do this, but if I were to pick it up and put it in another spot, it would just continue nesting just because those hormones are flowing. So if you were a predator, that's kind of easy prey. Turtle's just kind of sitting there, and then there's also the eggs as well. So I'm saying that one reason why they might have fidelity is to reduce search time. So if they can just go back to the same spot every year, they don't really need to look for a nest. Once they find a good spot, they can just keep going back to that same spot, reducing search time and reducing then the chance that they come in contact with a terrestrial predator. So that's one reason why I'm saying that nest fidelity might occur. So the reason why I'm saying nest fidelity might not occur is if these females are just nesting in very high densities. The predation will be too high, and then there's really no reason for them to come back to the same spot. They're going to want to travel a bit further away from the better areas. And so far, I found out that full-time on land, there's a positive trend with as you get older in age, the amount of time you have on land increases. And then I had very significant results with number of nesting attempts. So as turtles get older, the amount of nesting attempts that they're doing greatly increases, a very strong positive trend. So what's that saying? Basically the opposite of what I thought. I thought as a turtle got older, it would gain nest experience and therefore know where it's going, but I found that they greatly increase as they get older. Right now, I'm not sure exactly why they do this. Like there's probably multiple things why they could do this. The reason I think they might be doing it, turtles, because this is such a risky event in their lives, in the first couple of years, if they're spending all this time and they get predated, and they're not passing on many eggs, they're not, I guess, not passing on their genes to the next generation. So if they kind of, in their starting years, go up and kind of just pop their eggs anywhere, every year kind of building on that experience, finding better locations, that sort of thing. Because turtles live so long, by the end of their life, I'm sure they'll then have this this perfect location where they can just go back and eventually have, instead of potentially dying off very early, live a long time and then have many years of eggs and clutches there, and the chance of their genes passing on would be then a higher percent.